Alrighty, good morning geometry. Earlier this week, we looked at section 4.1 where we talked about the slope and equations of parallel lines, and we saw that again, parallel lines have the same slope. Today we're going to talk about perpendicular lines. They're all have something funky going on with their equations. So learning target today says I can use slope to write the equation of a line that is perpendicular. Again, that means intersecting at a 90-degree angle to a given line. And we're also going to talk about slopes being opposite reciprocals of each other if they're perpendicular and what exactly that means. Pause if you need to get learning target written down. First thing we'll talk about today is the slope criteria. So again, what exactly it means to be opposite reciprocal. So this is a quote directly from your book. The product of the slopes of any two non-vertical perpendicular lines is -1. So let's think that line 1, let's say that it has a slope of m, right? Where I was thinking mx plus b. So line 2, it has to have another slope, and we know that the product of those slopes, so if I take both of these and multiply, then it equals -1. So m times, I'm just going to say question mark, the slope of the second line. We're going to solve for it in just a second. M times the slope of the second line, whatever that may be, is equal to -1. So if we had to solve for question mark, it's just a quick divide by m on both sides. It's kind of abstract because we're talking about, moving variables around, but it's still the same thing. If I want to solve for question mark, get those m's to cancel by dividing by m on both sides. Therefore, the slope of my second line here is -1 over m. All right? So again, we're assuming that these two lines are perpendicular to each other. That means that their slopes are opposite reciprocals, all right? So opposite just means if your slope is positive, then the other one has to be negative, or if your slope is negative, then your other one has to be positive. So for opposite here, think about changing the sign. Reciprocal, think about flipping the fraction. So when you look at line 1 and line 2, their slopes, I'm going to get rid of that circle, that's going to drive me crazy. Their slopes are opposite of each other. One of them is a positive, one of them is a negative. And they're reciprocals because while here I have m, another way to write m would be m over 1. So if I wanted to flip that fraction, you would have 1 over m. And that is what we see in the slope for line 2, all right? So I think this would be a great thing to get down, this idea that multiplying their perpendicular slopes together will give you -1 because they are opposite reciprocals, all right? Let's just throw some ideas of opposite reciprocals out there. So let's say that I have y equals 4/5 x plus 2. If I had to write a line that would be perpendicular to this, let's say, we'll make it opposite, so we'll make it a -5 over 4x plus 10. Why not? We'll change that y-intercept as well. So again, these two would be perpendicular because their slopes are opposite reciprocals. How about another one? We'll do this in pink. What about y equals -3x plus 2? Then the opposite reciprocal would be a positive 1/3. So 1/3 x, and then we can just give it any, let's do -101. Those would be, again, perpendicular lines. Their slopes are opposite reciprocals of each other. Doesn't matter what the y-intercept is right now, but we know that those two lines have to be perpendicular. Okay, so if you wanted some concrete hard steps to follow for when we're finding equations of parallel or perpendicular lines, this might be something that you want to write down. So first, it's going to say, the problem's going to say something like, given this equation of a line, find an equation of a line that's perpendicular to it that goes through this point. So first you need to find the slope of the given line, right? It may be in slope-intercept form, so you can just identify the m, the slope, y equals mx plus b. Maybe you need to put it into slope-intercept form, so maybe rearrange some of your terms. Or if you were given 2 points that lie on the line, or you were given like the endpoints of 2 segments, hey, you could just use the slope formula to find the slope between those 2 points. So either way, you're going to find a slope between that given line. And then you're going to think about how you can start to write your new equation for your new line that is either parallel or perpendicular. So I like to just start off with y equals mx plus b, and then we can input the information that we know. Again, you're going to use the slope that you need depending on if you're finding parallel or perpendicular lines. So maybe you're going to use a line that is parallel. You're going to use the same slope from your given line. Or maybe you're going to look at a line that is perpendicular. Then your slope is going to be the opposite reciprocal of that given line. And then you're going to use the given point. Again, this line goes through the point, and you're going to substitute its coordinates for your x and your y variables, similar to what we did earlier this week. Then you're going to have an equation all in terms of b. You're going to solve for b, whatever your y-intercept is. Finally, then you can write your new line now that you know what the slope is, what m is, and now that you know what the y-intercept is. We're going to go over an example or two. So we had a couple examples where we were looking for lines that are parallel that go through a given point. Now let's go through some examples with those steps that you just wrote down for lines that are perpendicular to a given line that go through a point. So for this first one, I'm going to zoom it up a little bit more. We have a given line of y minus 4/3 x. I'm just going to write this out one more time. Y minus 4/3x equals 1. I want a new line, the equation of a new line that goes through this point, 4, 8, such that that new line is perpendicular to this guy here. Before we can start, let's try and find what the slope is of this given line. It's not in slope-intercept form, so to get it into slope-intercept form, where we have y equals mx plus b, I'm just going to add 4/3 x to both sides. All right, now I have my y's like solved for, right? Now I have y equals, it's looking more like slope-intercept form, y equals 4/3 x plus 1. And hey, now I see that my slope here, I'm going to say that the slope of the first line, so I'm going to say m1, is equal to 4/3. All right, let's focus on writing that equation for our new line that is perpendicular to y equals 4/3 x plus 1. I'm going to start with just the basics, y equals mx plus b, and I can substitute in my slope. I know that it has to be perpendicular, so I'm not going to write 4/3 as my slope. I'm going to find the opposite, so 4/3 over there, it's a positive 4/3. So I'm going to write negative. And then the reciprocal just means, think about flipping your fraction. So instead of 4/3, I'm going to write 3/4. So my slope of this line has to be negative 3/4 x plus b. Now I can say, let's plug in that point. Again, I'm going to take that point, 4, -8, plug it into wherever I have a y and wherever I have an x. So my x coordinate from that point is -8 equals negative 3/4 multiplied by my x coordinate, which is 4, plus b. Now we just have to solve for b, because this equation right here is all in terms of b. And that's the last piece of information that I need in order to write my new equation for the line. So I'm just going to quickly multiply here. -8 equals negative 3/4 over 4. You can see that the 4 on the bottom and multiplying by a 4 on the top is going to cancel each other out. We're going to be left with -3, or we could just multiply straight through. We'll still get left with -3. So multiply fractions straight across. I'm going to have 3 multiplied by 4 is going to give me, it's going to be a -12 over 4 plus b. Simplify that down. There we go. We still have that -3 plus b. Last step, I can add 3 to both sides, and I'm going to get that b equals -5. Now that I have my y-intercept, I can finally finish off and say that my equation of this new line, I'm going to write it in pink here. Ooh, that's really big. Y equals -3/4, that opposite reciprocal slope. So -3/4 x minus 5. All those pieces put together give us that new equation. Okay, one of my last examples here, we're going to deal with a horizontal line. So I want to find an equation. So here again, I'm going to start with like an area for my work for my new line that is perpendicular to y equals 3. Just so we can, I love sketching things out, just so we can see exactly what y equals 3 looks like. I know it's going to be a horizontal or a vertical line. Let's go find where y equals a +3. Let's just call it right up there. That means that everywhere along this dotted line right here, y is equal to 3. So I know that I have a horizontal line, y equals 3. Just to show the algebra, let's see if we can put this thing into slope-intercept form. So again, slope-intercept form looks like y equals mx plus b. I currently have y equals just a 3. So the only term that is missing there is the m times x. And we said that horizontal lines have a slope that is 0. So if I have a slope that is 0 being multiplied by my x, it's just all going to be 0. So it's going to disappear. So technically, there is a hidden 0x in front of that +3. All right? So again, y equals 3. Another way to write the same thing is y equals 0x plus 3. Right? It has a slope of 0, obviously. So if I wanted to find a new line, the equation of a new line, I could say that y equals mx plus b. Again, we're looking for lines that are perpendicular, so the opposite reciprocal of 0, well, I could write this as 0 over 1. The opposite reciprocal of that would be -1 over 0. And hey, you can't divide by 0, that's undefined. We know that undefined lines have equations that look like x equals a number, right? Because x equals a number, that is going to be a vertical line. So maybe like x equals 3. All right, that vertical line there has a slope that is undefined. So technically it's got to be perpendicular to my horizontal line. So that's essentially what we're doing. If you have y equals 3, a perpendicular line to y equals 3 would be x equals 4, right? So I know that my new line has to be in the form of x equals a number. And I know that this point goes through, or that line, x equals a number, it goes through the point 2, 14. So what is my x coordinate from here? It's got to be 2. So the equation has to be x equals 2. So again, if I had to sketch this out, I'll go off to the side here. There's my coordinate plane. In red is my vertical line, x equals 2 there. And in blue is going to be the horizontal line, y equals 3. So these two are perpendicular. They intersect each other at 90 degrees. And I am ensuring that this red line, x equals 2, it's definitely going to go through the point 2, 14. This is one of my favorite word problems that we can do. So a ship is in distress located at the point shown on the grid. So the ship is currently at this point over here at 0, 4. The quickest way to reach the shoreline is to direct the ship along a line that is perpendicular to the shore. And we see that the shoreline is represented by this red line going right through here. All right. We're going to have to basically find a line, the equation of a line, that is perpendicular to that red line there, so that the captain can, say, hey, follow this line. We'll get to the shore the quickest, right? Because obviously, if you're trying to get, here's the shoreline. If you're out here, you're going to want to go straight towards the shoreline at a perpendicular angle if you're trying to get to safety. You don't want to swim and then you'll make it, right? You want to go directly there. So let's figure out first what the equation of the shoreline is, because then we can find a line that's perpendicular to it. So I'm going to say that the equation, or that the shoreline, I know that one point is at 0, 7. And if I look over here, another point is at 3, 6. So the slope between those 2 points, we could use slope formula, or you could just recognize, hey, how much am I running? I'm running 3, and I'm falling 1, right? So since this is a negative slope, the slope of my shoreline is -1/3. All right, so the slope of that line, we can just look at those points, find the rise and run, and say that the shoreline, its slope is -1/3. So a slope that would be perpendicular to -1/3, we got to think about the opposite reciprocal now. The opposite reciprocal of -1/3 is just a +3. So the ship should use a slope. I'm going to say M. I'll say M2 for the second line. We'll say M1 is the slope of the first line. So the ship should use a slope of a +3. If we need to build an equation so that it has a slope of +3, but so that it goes through this point, 0, 4, where the ship is currently at, let's just use that slope-intercept form, plug in everything we know, and see what we can solve for. So here is the ship's course of action. Y equals, wow. There we go, y equals mx plus b. I know that the slope has to be 3. I know that it goes through the point 0, 4, where 0 is the x coordinate and 4 is the y coordinate. The only thing that I don't know is that leftover y-intercept, the plus b on the end. So that's something I'm going to have to solve for. And hey, check it out. 0 multiplied by 3 is just 0. So now I have 4 equals 0 plus b, which is just 4 equals b. Pretty simple. Now that I have that final equation there, now that I have that final y-intercept, I can finally put this together and say that the ship should follow the path of y equals 3x plus 4. All right, pause if you need to. I will see you in Blackman 107 for a little bit of review. Again, slopes for perpendicular lines are opposite reciprocals of each other.